Okay, so in this lesson, we're going to be learning how to solve trig equations of a more complex type. We know how to solve basic trig equations such as sin of x equals to -2/3, right? Between the range of 0 degrees and 360 degrees. But what if we have a more complex equation where there's more than one of our trig functions? So let's take a look at this example here. Let's say we have the equation 2 sin x minus 3 cosine x equals 0, which we are to solve for angles within the range of 0 and 360 degrees. So one thing we can do is we can start by transposing that minus 3 cosine x to the other side of the equation, and in doing so we'll add it to 0, and so it becomes positive 3 cosine x. So when we look at this equation, we notice that there are two trig functions, but we don't want to solve it with two trig functions. In fact, it's rather impossible to do so algebraically. So what we want to do is we want to get rid of the two trig functions and reduce it to just one. We can do so by dividing both of these sides of the equation by cosine x. In doing so, on the right hand side, the cosine x will cancel and you're left with just 3. On the left hand side, sin x divided by cosine x gives us one function, which is the tangent of x. So we have that 2 times the tangent of x is equals to 3. Now there's only one single trig function. To solve for this, then we transpose the 2 and divide by it. Then to solve for x, we do the inverse tangent of 3/2, which to the nearest whole number will give us 56 degrees. But remember, we're solving for x within this range of 0 and 360 degrees. So within that range, there will be two values. Our first value is in quadrant 1, where all trig functions are positive. And since it's tangent, the other quadrant where tangent is positive is quadrant 3. So to find that other angle, we add 56 to 180 and we get 236 degrees. So our two answers are 56 degrees and 236 degrees. Another way we can solve that equation is via the graphical method. So first, let's get a little bit of the basics of what the sine, cosine, and tangent graph look like. So the sine graph is simply this waveform that we are familiar with already via physics. Something to note is that if you are to double the coefficient of the variable x, then your graph has double the frequency. And if you were to triple the coefficient, then it has triple the frequency. Similarly, when it comes to the cosine of x, if you double the coefficient, you double the frequency, and you triple the coefficient, the frequency is also tripled. Something important to note comparing the sine and cosine function graph is that they are both periodic with a period of 360 degrees or 2 pi radians. The difference though is that the cosine starts at 1 on the vertical axis, meanwhile the sine starts at 0 on the vertical axis. However, they both have the same frequency as was stated. When it comes to the tangent of x, the graph is not periodic with a period of 2 pi, because remember, the tangent of 90 degrees and 270 degrees are undefined. Those do not exist, so there's a discontinuity in the graph. The graph looks like this. It's not a wave like the sine and cosine, but instead this irregular shape here. The tangent of x has a period of 180 degrees or pi radians. If you were to double the coefficient of x, then just like with the sine and cosine, the frequency would get doubled. You notice there are twice as many on the graph now. Same thing for 3x. So when it comes to solving our equation, we had the equation as 2 sin x equals 3 cosine x when we had rearranged it. So we plot both of those and we see where they intersect. Their intersection is the solution of the equation. So here the solution is 0.983 radians, which converted to degrees is approximately 56 degrees. And our other point of intersection here is 4.124 radians, which again converted to degrees is 236 degrees approximately. So whenever you want to solve trigonometric equations graphically, all you do is you plot the two functions, or 3 if there are 3, and you see where their points of intersection are. And the points of intersection are simply the solutions, the x values, that is. Okay, so in this example, we're to solve the equation cosine squared x plus cosine x equals sine squared x for the range between 0 and 360 degrees. Now, in this example, unlike the previous example, we cannot simply just divide both sides of the equation by cosine, because we have here cosine squared and we have here sine squared. So if we were to divide both sides by cosine, the cosine would only cancel with one of them here, and you will still be left with a cosine. Here, you would get sine times tangent because we have an extra sign. So that would not help. If we were to divide by cosine squared, right, that would not be good as well, because then although it may give us 1 here and it may give us tangent squared here, we would be left with 1 over cosine in that instance. So we'll still be left with 2 trig functions. So to solve this one here, the strategy would not be to divide by cosine. The strategy would be instead to replace sine squared with 1 minus cosine squared using our basic trig identity. So in doing so, then I can transpose all of this on the right hand side to the left hand side. So I'll have cosine squared x plus cosine squared x plus cosine x minus 1 equals 0. Simplifying that, I'll have 2 cosine squared x plus cosine x minus 1 equals 0. When I look at this equation here, I should look at that and realize that is a disguised quadratic. So I can say let p equal cosine x. If I let p equal cosine x, then this will become 2p squared plus p minus 1 equals 0. So I have a quadratic equation here which I can solve using any manner I wish. I can use the quadratic formula, or I can factorize, whatever is your preference. If I factorize it, it will become 2p minus 1 times p plus 1. So either the 2p minus 1 is equal to 0 or p plus 1 is equal to 0, which will give you that p is equal to 1/2 or p is equal to -1. Now recall that p was equal to cosine x. So we have only solved p, we haven't solved for x. To solve for x, I then replace p with cosine x, so I'll have that the cosine of x is equal to 1/2 and the cosine of x is equal to -1. So to find x, I'll find the inverse cosine of 1/2 and the inverse cosine of -1. So the inverse cosine of 1/2 is 60 degrees, and the inverse cosine of -1 is 180 degrees. Now, this 60 degrees is in quadrant 1. I can find another answer for that. If it's cosine and it's positive, then that means that the 2 possible answers are in quadrant 1 and quadrant 4. So in quadrant 4, I subtract 60 from 360 and leaves me with 300 degrees. So for this equation, there are 3 answers: 60 degrees, 180 degrees, and 300 degrees. And so with that, we then come to the end of this lesson. See you in class.